Hey calculus kids, this is Dr. Callahan with week 14 Tuesday. How are you guys doing? Go ahead and pause the video and take a look at the warm-up. There are 3 questions. All right, so question number 1 asks you, how do you find the critical point, inflection point, maximum, and concavity? So go ahead and take a look at the steps to do that. And let's go ahead and take a look at this question number 3 here. It says, determine the concavity for this question, whether it's concave up or concave down. So first thing I'm going to do is I would like to find the first derivative of this. So the first derivative, you will have to use the quotient rule. So let's have f equals 6, f prime is 1, and then g is going to be x squared plus 3, g prime is 2x, and then g squared is going to be x squared plus 3 squared, or x to the 4th plus 6x squared plus 9. So we'll see which one we have to use. All right, first thing I'm going to do is I am going to do f prime times g. So that is going to be x squared plus 3 minus f times g prime, that's a negative 12x. I want to go ahead and rewrite this. So I have x squared minus 12x plus 3 all the way over x squared plus 3 squared. And so far, there is nothing that I can do to go ahead and cancel this out necessarily. I just want to make sure f prime times g, everything is copacetic and good. Oh, you know what? I just realized I made a big typo here. F prime should be 0 because derivative constant is 0. So I kind of screwed up here. So give me a second, let me fix this. So that's gonna give you a 0, just a negative 12x. There we go. There we go. Sorry about that. Got a little bit ahead of myself here. So now once I have this at this point, this is the first derivative. And you can go ahead and set both of these equal to 0. So the numerator is going to give you a negative 12x equal to 0, x equals 0. That is going to be your critical point 1. And then your denominator is going to be your critical point 2. Set it equal to 0. So then square root both sides, x squared plus 3 equals 0, minus a 3. So x equals the square root plus or minus of negative 3, which you can't have that because it's an imaginary number. So you just really have one critical point. So then what you're going to do is at this critical point, you're going to go ahead and test it. It's at 0. And you're going to find f prime of negative 1, f prime of positive 1. You're going to plug that into the original equation and see if it's going to be a positive slope or a negative slope. Best way to do that is probably just by graphing. However, if you don't have a graphing calculator, like I don't have one right now, you can try negative 12 times a negative 1, which will give you a positive 12. And then, of course, a negative 1 squared is a positive 1 plus a 3 is a 4, 4 times 4 is a 16. So regardless, you're going to have a positive here. Okay, do the same thing with a positive 1. Negative 12 times a positive 1 is a negative 12. And then positive 1 squared is a 1 plus 3 is a 4. 4 times 4 is a 16. So regardless what you have on the bottom, it's still going to be a negative. So what you can see here is you have a positive slope followed by a negative slope. So obviously at this point, it is a max. So your maximum is going to be at 0, comma, f of 0 to get the y value for your maximum. And if you plug in the 0 back into the original equation, which is right here, 0 squared plus 3 is still 3. So then 6 divided by 3 is 2. So then your maximum is at 0, comma 2. So that is the first derivative test. Now for your second derivative, you would have to go ahead and most likely either do quotient rule, or let's see if we can maybe do product rule. No, we're going to have to just do quotient rule. All right, so then f double prime of x, and we're going to go ahead and work this for concavity on the side. So then I'm going to say that my f, if my pen works, come on, is going to be negative 12x. So f prime is a negative 12. G is a 2, or I'm sorry, is an x squared plus 3 squared. You will have to use a chain rule for that. So G prime is, bring the 2 down, 2 times x squared plus 3 times the derivative of x squared, which is 2x. Of course, I want to rewrite that just so I can make it a little bit more simpler now before I have to put it back into the formula. So my G prime is going to be 4x, x squared plus 3, and that is my G prime. Then, of course, you need to have your G squared, and your G squared is just going to be x squared plus 3 to the 4th power. All right, let's go ahead and plug it back into the equation then. So then your equation is f prime times g, which is going to be a negative 12, times x squared plus 3 squared, minus f times g prime, or I'm sorry, yeah, f times g prime. So negative 12 times 4 is a negative 48. So that's going to make that a positive 48. X times x is an x squared. And then you have x squared plus 3 all the way over. And you have an x squared plus 3 to the 4th power. Now, as I'm looking at this, it looks very ugly in the numerator. So let's go ahead and try to maybe make this look a little bit better. And to do that, I would have to first, I would have to distribute this part here, but now I also have the FOIL here. So my plan is to go ahead and FOIL the top, and I'm going to do one on the side over here so I have a little more room. So I have a negative 12 times x to the 4th plus 6x squared plus 9. Distribute that, I have a negative 12 x to the 4th minus 72x squared minus 108. Okay, and that's just this part right here. And then I'm going to have to distribute this 48 into that. So I have a positive 48x to the 4th plus, that's a 24, 12, 144x squared. Okay, so let's go ahead and combine the like terms. Negative 12 plus 48 is going to give me a 36x to the 4th. Then negative 72 plus 144 is going to give you a 72, positive 72x squared. And then minus 108. Okay, so this is your numerator right here. Now from this, I can see that I can take out a 36, and that will give me a x squared. Trying to think, I think I did something wrong here, but I'm not quite sure what happened. 36x squared. I know I made a mistake here somewhere. I'm not quite sure if I can go all the way back. Or you know what? Let's just keep going with this. Let's see what we can lead to. So 72 divided by 36, I can get a plus 2x to the squared. This should be a 4, not a minus 108 divided by 36 is going to give me a 3. Okay. And I can go ahead and factor the bottom part, or I can go ahead and have the 36 right here. See if I can factor this out, x and x. And I can do a -1 and a +3. Like that. Oh, that actually worked out perfectly. Yay. I'm like, great, I don't have to redo this. Because what you can see is this is your numerator. Do you see right here you have an x squared plus 3? That cancels with this. So that means f double prime of x is equal to, in the denominator, you have an x squared plus 3 to the third. And in the numerator, you have a 36 x squared minus 1. Oh, come on, you darn pen. Okay, so at this point, what you can do is you can take your numerator and you can go ahead and set it equal to 0. And what I'm going to have here is if I set the numerator to 0, I'm going to have just x squared minus 1 equal to 0 because that 36 doesn't matter. I can go ahead and add the 1 on both sides, square root the 1, so then my x is going to be a plus and minus 1. Okay, denominator, set it equal to 0. You're going to go ahead and cube root of 0, which is still a 0. But then what you're going to see is once you subtract a 3 on both sides, you cannot have a point of inflection where you're going to have a plus or minus square root of -3. So that's just not going to work. So let's just cross this one out so we don't get ourselves confused. And then we're going to go ahead and take the point of inflection, which is that right there, and start my sight line at -1 and +1. Okay, so we're going to go ahead and test our concavity. F double prime of -2, F double prime of 0, F double prime of 2. Okay, and you're going to plug it into the second derivative formula. So then if you don't have a calculator, like I don't have one right now, you could try to do this in your head. So you have a -2, -2 times a -2 is a +4, 4 minus 1 is a 3, 3 times 76 is going to give you an 108. So that's going to be a positive, okay? So regardless, it's a positive. Or actually, I'm sorry, it's a positive, but then if you put the -2 in here, still going to be a positive, so it's definitely a positive. Okay, now if I do a 0 in here, 0 minus 1 is going to be a -1. -1 times a 36 is going to be a -36 in the numerator, so remember that. Negative divided by a positive on the bottom is going to be a negative, okay? And then a 2. 2 squared is 4. 4 minus 1 is a 3. 3 times 36 is going to be a positive in the numerator. But then the 2 is also going to be a positive in the denominator. So positive divided by a positive is still a positive. Okay. So then there you have it. You have your concavity up, down, and up. So then what you can say is, I have a concave up in interval. Concave up is going to be between intervals -infinity up to -1. And also you could put a union there. You could do a 1 to positive infinity. And then you can say concave down. And of course, it's because f double prime of x is going to be greater than 0. Okay, and then it is concave down in between -1 to +1. And you could say because f double prime of x is less than 0. And that is your answer. I know it looks absolutely crazy, but in some ways it is also very, very elegant. So yeah, that was a good one. And I'm actually going to keep that work for next year because that one is a massive amount of work that we just did. All right, cool. Let's go ahead and move on to the next part. All right. So last time I saw you guys, we went over a few questions on concavity. I did give you guys notes, and we filled this part out. We went over 2 different examples. I did have a calculus puzzle right here that if you didn't get to, that's okay, because today I'm going to give you guys a little bit of opportunity to kind of go through a few of them. This is the breakdown of what we're going to be talking about today. I would like you guys to take a look at the Quizlet. So this right here in the yellow, everything is lowercase, but once you go ahead and type that in, you will be able to see this part right here. Oh no, okay, never mind. Maybe we won't do this one right here, because now they're charging you. Because before it was free, and now they're charging you. Well, that's not very nice. So never mind. Let's not do that then. Last year it was free. This year apparently, you have to pay $6.99 for it. Boo. All right, that's okay. Let's go and take a look at our guided notes today. So go to week 14, Tuesday, and your first page should look like this, okay? It's the calculus puzzle. Second one is right here. This is your guided notes for today. Third one is I have 2 free response questions from previous years that deals with what we're doing today, or what we're doing right now is concavity. And of course, I have the links right here that you guys can go ahead and type in to go ahead and take a look at the answers. So if I go ahead and click on the first one, this is what it looks like, and I want to make sure I share it with you guys. So take a look at that. Okay, so the breakdown of the questions is A, B, C, D. And if you look at this, A, you get 2 points if you have these 2 answers. B, 2 points if you have the intervals and the reasons. C, if you have the 2 answers. And then, of course, D. And this one is the one where I showed you that these are some of the answers that other kids have done in the past. So I would suggest that you take a look at it and kind of hone in on the answers there. And then, of course, there's the second one, which I'm going to share with you guys as well. Which looks like this right here. Okay, and once again, you have the answers broken down. You're using the quotient rule. In the very beginning, you do have the integral, which we have not talked about, but we will during the second semester of this year. And if you look at it, it's kind of like a culmination of everything you learned from the first semester and second semester combined. But once again, you have some of the answers that other students have written. Take a look at how they show their work, etc. And one thing I have to tell you is that on the AP exam, if you're not sure about the answer, do not erase it unless you have the new one written out, because you're timed. And one of the strategies I've seen students do over and over again that they fail to use is that they get frustrated with their work because they thought they made a mistake. Then they erase everything before they even have the time to write the new answer. Don't do that, okay? You can always write the new answer first and then just cross out the old answer. It's a lot easier than to start erasing, because that really does take away your time. And so just go through this one, take a look at the answers, and take a look at how they are showing their work. Like this one, for example, the student actually, with words explained their thoughts, which I think is important, because in the past, some of the students just simply wrote down the answers and that is it. And of course, you have the overview of the questions on the very bottom. Okay, so let's go back to this. All right, so today you guys have, like, basically it's your choices. Right before Thanksgiving, I'm gonna give you guys an option of picking any 2 things to do. You could do the calculus puzzle, you could do the 2 questions with the videos, you could do the 2 free response with the steps, you could do the poster rotation, and you could just pick any 2 of your choice. Now with the question with the videos, let me just show you where it is. It is going to be right here, and this is what it looks like. You have a link for the video. be careful with the capital E and capital W. Another thing that you can do is the poster rotation. And so I'm just going to show you the poster itself, and then you can take a look at it. The link on top, which I didn't have time to convert it to a QR code, which I did because it'd be so much easier for you guys to watch the video, is right on top. You can type that in, but this is poster number 1, poster number 2, and again, the video axis is on top, poster number 3, poster number 4, number 5, number 6, number 7, number 8, and lastly, number 9. You're welcome to pause the video, of course, to do that. And again, the links are on top to watch the video. Okay, so then what I would like to do is go over this question right here with you guys in class. So turn over to this page. It's 2 questions. You guys are welcome to actually work on the first question by yourself and see how far you get, because the first question is actually the easier one. And the first question looks like this one right here. Okay, so go ahead and pause the video, give that a try. And here are the steps to it. You guys are welcome to take a look. With the first derivative with the sine line right here, to the second derivative to find concavity. All right, so let's go ahead and give the second one a try. Okay. Here's the second problem. So we're going to find concavity first. I'm sorry, the first derivative first. And of course, my pen is being a pain in the butt right now. So f prime of x, you're going to have to use the quotient rule just like we did before. And so f is going to be 2x squared, f prime is 4x, g is 9 minus x squared, so g prime is going to be negative 2x. You want to make sure you check your answers first and make sure it's correct before you proceed any further. G squared is a 9 minus x squared squared. All right, so then first thing I'm going to do is f prime times g. So I'm going to distribute that, and that's going to give me a 36x minus 4x to the third. Okay, minus f times g prime. So that's going to be a negative 4x to the third. And if you look at this, I can combine this together, which would give me 36 minus 8x to the third, all the way over 9 minus x squared squared. Okay, so then remember, for your critical point, you will have to set each of these to 0. So the numerator equals 0. You subtract the 36 on both sides. I just noticed I made a little mistake. So the mistake that I made here is it's f prime times g minus, but then if I look over here, positive 2 times a negative 2 is going to give me a negative 4. That negative times this negative is a positive, so these two actually just magically cancels. And I call myself that because I'm like, there's no way 8 goes in the 36, and I don't think they will make it so that, I wouldn't set it up so that it's not going to be actually a perfect number. It wouldn't be in decimals. So lucky for you, this is actually just gone. Okay, so you don't even have that. So it'd be just 36x. So the first critical point is just x equals 0 from the numerator. Then your denominator, you're going to set that equal to 0, square root both sides. 0 square root of 0 is 0. Minus an I on both sides, you'll have a negative 9. Divided by the negative 1, you get a positive 9. So what is the square root of positive 9? Plus and minus 3. So it's like little tricks like this is good to have because that way you know you're like, okay, wait a second, that doesn't make any sense. It wouldn't have like a crazy decimal for me. All right, so let's do the sign line. And you're going to go ahead and pick a point in between them. So f prime of -4, f prime of -1, f prime of 1, f prime of 4. Go ahead and plug the critical points in, and you're going to find out that the first one, you're going to have a negative, f prime of -1 is a negative, f prime of +1 is a positive, f prime of 4 is a positive. So if you're looking at this, it's a negative slope, positive slope, positive slope. So really there is just one minimum, and that minimum is at 0, f of 0. And so here is your f prime. So if you put in 0 here, it is going to give you a 0 on top. So your minimum is just be 0, 0. Okay, so then let's find the second derivative. So with your second derivative, we're going to go ahead and do the quotient rule one more time, which is a pain in the butt. I completely understand that. Your first derivative is right here. I want to make sure I highlight it so that way you guys don't get confused and get your f prime and g primes incorrectly. So f prime for the second derivative, or I'm sorry, f is going to be f is going to be 36x, so then f prime equals 36. Your g is going to be 9 minus x squared, so be careful with that. And so then your g prime is going to be chain rule, 2 times 9 minus x squared to the 1 power times -2x. And then you're going to rewrite it, so it'll be a -4x times 9 minus x squared. And then g squared is just going to be 9 minus x squared to the 4th. Okay, so then let's go ahead and plug that in into the formulas of f prime times g is going to be a 36 times 9 minus x squared minus f times g prime. So I'm going to be careful with this because of the minus, because everything becomes a negative then. 36x times a -4x is going to give you, that's a 24, 12, 144. So it's going to be a negative 144, but because with this negative, it's going to be a positive 144 x squared, 9 minus x squared. Oh, I'm sorry, that matters. Don't put the square outside. That it's a minus x squared with a close parenthesis. Yeah, that's important to have. Okay. Next we're gonna do is you would have to do exactly what I did with the warm-up. You would have to FOIL this part and then distribute the 36. And I would prefer to do that on the side so that way I don't mess this part up. But before I proceed any further, I just want to visually see this and make sure I didn't make any mistakes. So f prime times g, so that's 36 times that, that's correct. And then minus, that looks good. Okay. Yeah, you want to just make sure you do this correctly before you proceed any further because it's going to take a lot of time to undo that work. All right, so let's go ahead and FOIL then. If I FOIL that 9 minus x squared, I'm going to get an 81 minus 18x squared plus x to the 4th. Yeah, we have to do this backwards. And then you have a 36 right here. And then I'm trying to think if there's an easier way to do this besides going through all this work. Actually, you know what? There is an easier way of doing this. I just noticed this because as I'm proceeding with this, I'm like, no, that's not making it easier. That's making it more rough. So I actually did notice something. My f prime, a double prime of x, also has this part here in the denominator. So 9 minus x squared to the fourth. One thing I noticed about this is that you have this part exactly the same, but you can't just directly cancel it. You would have to factor the numerator. So if I factor the numerator, if I factor out the 9 minus x squared out, then what goes back in, you have the 36. You still have one pair of 9 minus x squared in there left, okay? Plus 144x squared, but then that won't have the 9 minus x squared. So then 9 minus x squared to the fourth would mean that you can cancel one of them. Cancel the top, cancel the bottom, but the bottom you have 9 minus x squared to the third. Okay, and then what you can do is you can go ahead and start combining here. So then that you have a so you can go ahead and factor the 36 out, and then what you end up having is going to be a 36 times 9 plus 3x squared all the way over 9 minus x squared to the third. Okay, so now let's go ahead and find our critical point. Our critical point, if you go ahead and take the numerator, set it equal to 0, you're going to have a negative 9 divided by 9, and that's not actually going to give you... Okay, so I can see right now that the numerator is not going to give you anything. It's going to give you an x equals plus or minus the square root of a negative 3. So that's not going to work. So cross that out. Let's write down the denominator then. Set it equal to 0, you have a negative x squared equals a negative 9. But when you square root it, because that negative and this negative cancel, so it's positive, x equals plus or minus 3. Okay, so then you're going to go ahead and do the sign line. With a negative 3 and a positive 3, you're going to pick some points on either sides of this. So I'm going to have f double prime of a negative 4, which is going to give you, if you plug it in, it's going to give you a negative, so it's concave down. And then I have f double prime of 0, which is going to give you a positive, so it's concave up. And then I have f double prime of 4, which is going to give you a negative, so it's concave down. All right, so let's go and fill out this part right here, okay? Your x-intercept for this graph is going to be at 0, 0. Vertical asymptote is at when x equals 3 and x equals negative 3. Your y-intercept is at 0, 0. Your horizontal asymptote here is, if you look at this part right here, remember I taught you how to do horizontal asymptote. It's the same thing as finding the limits of positive infinity. So if you're looking at this right here, they both have a 2. So then what you're going to do is you look at the coefficient in front of the x squared. So the numerator have a 2, denominator have a negative 1. So then what does that mean? Y equals negative 2 is going to be your horizontal asymptote. Okay, and then from there, what you're going to do is your domain. And just like with a horizontal asymptote, they have y equals negative 2. The way you find the vertical asymptote is you just set the denominator to 0. So if you set this equal to 0, then 9 minus x squared, you'll find out that x equals positive and negative 3. Now the domain here for your graph is going to be from negative infinity to negative 3. And you're kind of looking at this sign right here. And then union from negative 3 to positive 3. Union, one more time here, then from 3 to positive infinity, okay? The interval of which it is going to be decreasing is going to be from negative infinity to negative 3, union from negative 3 to 0, because that's how you found your maximum. Okay, and then your interval of increasing is going to be from 0 to 3, union 3 to positive infinity. Your relative max is going to be none because there is none. Your point of inflection is going to be none. Your relative minimum is going to be 0, 0. Your concavity, where it's going to be concave up, is going to be at -3, 3. And then your concave down is going to be from negative infinity to -3, union 3 to positive infinity. And that is it, you guys. All right, so now what I would like you guys to do is maybe take this information, try to see if you're able to plot it on this graph right here and see what it looks like. And at the end, it should look something like this. All right, well, that was a lot of information to kind of take in, but the good thing about it is you'll have a few days to go ahead and digest this over Thanksgiving break. I hope you guys have a wonderful, wonderful time with your family. Stay safe and healthy, and I will see you guys in a few days. Take care.